Welcome again to Foundation Mastery Method Differential Equations. In this lecture, we'll be talking about Heaviside function, Heaviside step function, and the piecewise defined function and their Laplace transform. So first we check how to find step function, which is Heaviside step function, from a piecewise defined function. So we have a function like ft is defined like 0 when t is less than 1. It is 7 when is t lesser or equals 8, greater or equals 1. And it is 5 times t minus 3 when t is greater or equals 8. So we just use a number line and put all these t boundaries. So t is 1 and 8. And then we have the values which t is less than 1, it is 0. Between 1 and 8 we have 7. And after 8 we have 5 times t minus 3. So now how to derive the function? First, at t equals 1 we have u t minus 1, and at for 8 we have u t minus 8, and we put all these values at the top within the boundaries. Now the derivation will be like, first we have u t minus 1, and then the right side we have 7 and left side is 0. We take the difference, 7 minus 0. And then plus u t minus 8, and then we'll be taking 5 times t minus 3 minus 7. And then we simplify this one. So this is actually the Heaviside step function derived for the piecewise defined function ft. Now in this case we'll see how to find Laplace transform of this Heaviside function. So we have another example. Ft is defined as you see here. Now we make the number line, put all the t values we have step by step. We have a 0, 3, and 4. And then the values in between, so we type here. And now we write ut for t equals 0. And then you have t minus 3, t minus 4. And remember, ut is same as ut minus 0. So c is 0 in this case. Now the derivation will be ut, the first one you have leftmost, and then it will be negative 3 minus 0. Plus we get ut minus 3, the right hand side value is 3, and then we subtract the left hand side value. Plus ut minus 4, right side is 1 and left side is 3, so we subtract. And then simplify this one, we get this. Now let us recall the formulas we know for Laplace transform. U t minus c ft, when you want to take the Laplace transform, then it will be e to the negative cs, and then f, t will be replaced by t plus c. So that exactly we'll be doing in our Laplace transform. And just also to remember, the Laplace transform of any constant will be constant over s, as you know that. You can check this one in your formula sheet for Laplace transform. Now let us take the Laplace transform. So the first part is ut, that means c is 0, so we have e to the 0 times s, and we have negative 3, that becomes 3 over s with a negative sign. And then 6 also will come out as 6 over s, and e to the negative 3s. So we have this. Minus, so we have e to the negative 4s now, and 2 becomes 2 over s, and this is the Laplace transform of this piecewise defined function after we convert this one to Heaviside step function. So we just simplify and write the result. Next we want to solve a differential equation. As you see here, step function is needed. So we'll be deriving the step function as you can see here. Okay, and then taking Laplace transform, you know that second derivative will give me s square xs minus s times x0, and then x prime 0, and then 4x becomes 4xs. And then recall, if you have ut step function and then it's a trigonometric function, or just think like that. So you are taking e to the negative 0s, and then in this case we should have written Laplace transform, yes, because c is 0, that's why. So you get pi over s squared plus pi squared. You know that the Laplace transform of sine ct or bt, whatever you have in the formula sheet. Okay, and then same way when you have t minus 1, so as we have said that your t will be replaced by t plus c, and our c is 1. And now it's just simple trig identity, sine of pi times t plus 1. You can distribute pi, you get pi t plus pi. And then, as you see here, it is going in the third quadrant because you have pi plus, assuming like that. In the third quadrant, sine is negative, that's why negative sine pi t. So we just plug all this here. So after simplification and putting all the initial conditions, we get this excess function. Now we need to apply the partial fraction decomposition to find the solution of this differential equation in terms of t again. So on the right hand side now you can see how the Laplace partial fraction decomposition is done. So after solving for a, b, c, d, we have the following values. Put it back here and then apply inverse Laplace transform now. So first we separate our functions with e to the negative s and just a regular one. So the first part is direct, straightforward. We are going with sine function because it's 1 over s square plus c square kind of, or b square kind of. But the second part you have e to the negative s, so that will produce Heaviside function, as you see here, u t minus 1. And then we have 1 over s square plus 2 square, that becomes sine bt, but then t will be replaced by t minus 1.